Family number 6.
If you do it with something smaller, it'll melt. So, yeah.
Alright. Students are always like, oh, I can do this at home. I got a little. No. You can't. Right, and the isopropyl alcohol, we use 91%, but you can get it at Walmart for like $2.50 for that huge thing. We just add boric acid to make it green. There are all sorts of chemicals you know that make the fireworks colors. You can use those same ones. Alright, next. Anyway, you can only do it once. They use up all the oxygen. Oh, yeah, you can only do it once. We usually can do it about once in an hour, that demo. So what we do in between in the water jug is obviously there's water left over. We dump that water out, put fresh water in, spin it around, and dump that, and then let it sit for about an hour, and then it's ready to go again. We have like 3 or 4 of those water jugs that, in case something goes wrong, we can have another one ready.
Alright, so this next experiment is called milk of magnesia. Maybe you've heard of it, maybe you've done it before. But essentially, milk of magnesia is an antacid, and we just dissolved it in water. And we also added an indicator.
Add the general indicator.
Yeah, the general indicator. And we can use this, it's a good introduction to acids and bases. So what we're going to do is we're going to add HCl, hydrochloric acid, a little bit at a time, and see what happens.
And milk of magnesia is basic, so we get the green indication from indicator.
The first time I did this with the IMSA students, they literally oohed and awed for about half an hour. Huh? Hydrochloric acid. I'm pretty sure it's
1 molar. As you can see, I added a little bit too much. Normally we draw it out a little bit longer. We've shifted from the dark blue to more of a green. And when I first added it in, you had the pink right away, and then it shifted to a yellow, and then back to the green.
And if your students are a little bit older, this is a good place to introduce the Chatelier's principle, which is sort of like when you have an equilibrium system, if you add to either the reactants or products, it's going to shift in the opposite direction. So you can start explaining that to your students.
Hydrochloric acid.
If you're lucky enough to have one of the magnetic stirrer plates that also has a light in it, you can do this a little bit with titration. I've done it with titration type things before. Most basic chemistry classes, you're talking about titration, and the easy way to do it is with the acid base, so you can really genuinely see.
Working with your students, we use milk of magnesia, which is, like pharmaceutical. You drink it for stomach pain. It's an antacid, so you use it that. You can have students bring in household things, detergent, food, things that they are familiar and come into contact with every day, and you can show them how, if it's basic or acidic, and that just because something's neutral doesn't necessarily mean it's, the only safe thing to be around.
We've done something similar with 3rd graders, but instead of doing universal indicator, we made red cabbage juice indicator, and then they brought in toothpaste and laundry detergent, and we brought in Coke, things that they're exposed to at home, and then they tested the pH, which we can do it with 7-year-olds. You guys have more milk, right? Just you guys.
What color is neutral on this indicator?
Generally it's yellow.
So green is the base.
Green is the basic.
going back onto titration, a lot of times we point out to the students while we're putting the hydrochloric acid with a dropper. You're not adding a lot, whereas I poured the milk and magnesium in, I was just pouring tons and tons in. So you can tell that we have a stronger acid than we do base because it takes more base to neutralize our acid.
And I like the red chemistries because we actually go around the school building and test the different water fountains. Because the water fountain, or the water that's in the science lab is different than the water that's in the water fountain, is different than the water that's in the bathroom sink. Sometimes, like our water at IMSA is ever so slightly basic. Alright. Next, Alan's favorite. This is like Alan's.
Tesla-coil.
Joy.
How many of you have used a Tesla coil in class before? Or seen one used in a class? I don't know. A couple people. There's a lot of great experiments you can do with the Tesla coil that I do not get to use the Tesla coil for. But we can see them nonetheless. So, the way the Tesla coil works is that it gathers some electrons at the tip of it, and then you can, since humans are conductors, one of the things we talk about with younger children is conductors, insulators, and how we as humans are conductors. We can hold onto the tip, and the electrons will pass through us. Which means that if I were to, first I'll take off these rubber gloves, and grab a light bulb,
Oh yeah. Alright, so this is one of those, you want to make sure the students are wearing rubber-soled shoes, they're not wearing any rings or watches on their hands, remove cell phones from pockets, no pacemakers.
really anything metal should be done. We've learned that the hard way.
Alright, you ready?
Yes.
Sure?
Yes.
Do not let go.
And so you can also talk about how you can link together multiple people to create a longer chain for the electrons to go through. So actually, if I can get a couple volunteers to come down and help me. Nobody wants to do it?
Watching stuff.
Anything you want to metal?
Yeah, I'll see them others.
I'll take pity on you and hold the Tesla coil directly. But if you do hold the light bulb on each side, right over, not directly on the metal.
Don't touch the metal. Holding on to the light.
Still like a.
Do not let it. It's not going to be stuck. It's not. It's fun to. So you can talk about why it lit up between them, but not on the other side of him, not on the other side of his hand.
And another thing we can do then is, instead of putting it in between people, putting it at the very end of the chain and seeing how that affects how much it lights up.
Ready? Anybody else feel like Star Wars a little bit? That's just me.
As you can all see, was it brighter or dimmer when he held it compared to when it was between the two? It was dimmer. Anybody have an idea why? That is a good guess, and that's part of the reason why, but it's not the whole reason. The biggest reason, I can't actually see any hands in here, so if someone wants to shout out an answer. No?
Well, because it's going from one point down to the other versus just being at one down.
Exactly. It's going through and it's more completing the circuit. Which, as most people know, when the electrons from the Tesla coil will flow through you and actually through your feet into the ground, and it grounds you. And so that's why you can stand here and hold it, because the electrons are going into the ground. And so when you put it between two people, it's completing the circuit, and as we know, completing the circuit makes it work, or work better, depending on the case. Now, yes. Would you like to volunteer?
What happens if he lifts the foot?
Huh?
What happens if he picks up a foot?
Hang on, I can't hear. What?
If he would pick up one of his feet with he would
Yeah,
come on
we've done
ground
that.
and-
Yeah, we've done that.
Would
one.
that interrupt
Picking
the
your
surgery?
feet, jump, or having everyone jump.
Would you all like to see that one?
Yes.
Are volunteers okay with
It'll look better too.
jumping?
Can you back up a little? Thank you.
Make sure you're not touching the middle end of that. There we go.
We're jumping.
We're jumping on the count. All counts. Are you ready? Then we go. 1, 2, 3.
So,
Did you notice anything? Okay, so explain to your students that some of those electrons that are traveling through your body do go out through your feet, so your body's acting in them. All right, that's more. Who else wants to go? Let's line it up across the front. We'll go from this way.
the one
We're just going that way, so we can add more people. Eleanor's in. Brooke, are you in?
Shark in.
Any other teachers want to come down?